All right, welcome. In this video, I'm going to be talking about rates of change of polar functions, but not even really the whole thing, because we talked about, closer to the origin, farther from the origin when we were doing polar. There's just this one thing right here. Let me find it. I'm going to zoom in on it. We did the furthest from the origin or closest to the origin problems, as much as we can in pre-cal. It's this thing right here. The average rate of change of r with respect to theta. You know what? That's better. The average rate of change of r with respect to theta over an interval can be used to estimate values of the function within that interval. I never showed y'all how to do that in this class. We definitely kind of used a secant line to interpolate on the free response. I believe that's on frequently on number 2, part B. But we never did this with polar, so I just want to show you what that looks like. All right, so for example, suppose we've got this table of values here that gives us values of the function f of theta, and we're thinking about the graph of r equals f of theta in the polar coordinate system. These are the actual values of f. If r equals f of pi over 8 is estimated using the average rate of change of f on the interval 0 to pi over 4, I should probably say, I just didn't think to write that. Is it going to be an overestimate or an underestimate? Okay, so we're going to need to find the average rate of change of f first. Okay, so we're going to find that, and remember average rate of change, that's rise over run. We're going to say that's f of pi over 4 minus f of 0 divided by pi over 4 minus 0. Okay, we're going to pull the values from the table, f of pi over 4 and f of 0. We're going to subtract them. We're going to divide by pi over 4. I'm going to notice, 1 minus 1, this is really convenient. Okay, so I'm going to end up with 3 pi divided by pi over 4. And then I'm going to, if you can just know what that is, good for you. But if you're unsure about your fraction arithmetic, which I know a lot of people are, I'm going to think about dividing two fractions, keep the numerator the same, change the division to multiplication, flip the denominator, right? It still works. Okay, and so that's going to be 3 times 4, which is going to be 12. Okay, I've got my average rate of change. Now I need to figure out if it's an overestimate or an underestimate, so I'm going to actually estimate f of pi over 8. Okay, and so my estimate is going to be, all right, well, to get f of pi over 8, I'm going to start with the value I know. Well, you can really do this with either of them, but it's going to make a lot more sense to start with theta equals 0. Theta equals 0, r equals 1, or f of 0 equals 1. And then I'm going to add the average rate of change times the change in x, like how much did x increase by? We expected f to increase 12 every time x increased by 1. In this case, x increased by pi over 8 minus 0. So it's going to end up being 1 plus 12 pi over 8. I can simplify that to 1 plus 3 pi over 2, and I can use that to help me figure out if this is an underestimate or an overestimate. Okay. Thinking about 3 halves of pi, that's like 1.5 times pi. Well, pi is bigger than 3, and 3 times 1.5 would be 4.5. So this 1 plus 3 pi over 2 is definitely bigger than 1 plus 4.5. So I'm going to say that this is bigger than 5.5. And since I know that the true value of f of pi over 8 is 5, and my estimate was 5.5, I'm going to say that it was an overestimate. Now, if you were here for, closer to the origin, farther than from the origin type discussion, I don't want to just totally leave you hanging. So I'm just going to do one of these that came from the course description. Here's polar function f negative 1 plus sine theta. As theta increases from 0 to pi over 2, which of the following is true about the points on the graph of, the polar function in the polar coordinate system, which is on top of the xy plane. Okay, what we need to do is think about the rectangular graph. And if this is a negative 1 plus sine theta, I'm going to draw the graph of the standard positive sine x, sine theta, whatever. And I'm going to start with the vertical axis, okay, because I can see the midline is negative 1. And the amplitude is going to be 1 because I'm just adding 1 sine theta, so I can go up to 0 or down to negative 2. Horizontally, I'm not seeing a phase shift or any multiplier, so I know that I'm going to be starting at 0, and since there's no multiplier, the period is just going to be the standard 2 pi. And I can kind of fill in the values in the middle, halfway between 0 and 2 pi, and then halfway between 0 and pi, and halfway between pi and 2 pi. And now I've kind of got the tools that I need to make this determination. They're talking about on the interval 0 to pi over 2, so we're going through here. Okay, right there, what I've colored in red. I'm going to say that r is negative and increasing. Okay, so it's getting closer to 0. And in this situation, that does matter, right? Because the origin is r equals 0. I'm going closer to the origin, so the points on the graph are getting closer to the origin. Okay, so I'm going to get rid of these getting farther from the origins. And really looking back at the excerpt from the course description, it's really this thing right there that I just used. And for further discussion on this, you would want to go back and look at, like kind of chapter 10 videos on my playlist on polar for more detailed discussion on this. But for solving this particular question, we need to make this decision about, is it above or below the x-axis? This is a very interesting question. I have seen this when we worked it in my class. I just kind of forgot about it. So I'm going to kind of come over here to where theta equals pi over 4. I can see that r is negative. Okay, r of pi over 4 is a negative number. So what I'm going to do is I'm going to just kind of draw theta equals pi over 4 right there. And we know that r is negative, so I know that the graph of f of theta is like somewhere about there, right? I've gone backwards along pi over 4. So the graph is below the x-axis and getting closer to the origin. So that's going to be answer choice C. Okay, but really what I wanted to show you in this video was this business right here, how we can use the average rate of change to estimate values of a polar function. It's really no different from doing that on a different type of function, but it is mentioned in the course description. I'm just coming back through today and recording all of the last second videos of things I kind of forgot to hit from AP Pre-Cal Units 1, 2, and 3. I'm going to come back and do all the Unit 4 stuff at a later time, but that's all for this video. Thanks for watching.